Okay, we are going to go and go ahead and get started. I'm sure there will be more people that join us as we're going through here. Welcome everyone to the continuation of the series of webinars, sort of Tom's trek across Iowa, looking at weeds and invasives, and we've actually looked at a few native plants as well. We're glad that Tom is here to join us, is feeling better and ready to get started on this webinar. So you should have all received a handout with the plants that we have identified. Tom, I'll hand it over to Tom in just a little bit, but there's one correction that he would like to make on the handout, I believe, with a scientific name. But welcome everyone, and I'll hand over the presentation to Tom, and we'll do what we've typically have done. Tom will do an intro. And then we have Tiffany, who is joining us as well with iSwept, and she is going to run the video, and we'll start and stop the video at each of the different locations that we go to. So I'll hand it over to you, Tom. Welcome.
All right, thank you, Pat, and good morning, everybody. Yes, it's been a couple of months since our last webinar. I was not able to get out and get the video done last month because I had a case of Rocky Mountain spotted fever, unfortunately. I think it's the second case of Rocky Mountain spotted fever in Iowa this year. So, but I am fine after about 3 or 4 days of antibiotics and rest, back to normal. And Pat and I were out recording this video at the end of August, or excuse me, the end of July. We decided to, because we had a kind of a time crunch, we stayed kind of close to central Iowa and went to Ada Hayden Park on the north side of Ames. We thought we could find some good wetland plants there as well. So that's where we went. We'll go take a look at what we found there in just a little bit. The one correction that Pat was mentioning in the handout is with quackgrass. And this is just, this is maybe not so much of a correction, but just updating. As you probably know, I hope you know, the nomenclature is always a question. Which nomenclature one's going to follow, of course. I try to follow Flora of North America as much as possible. Flora of North America is not completely finished, though, so that leaves one sort of hanging with a few families of plants that aren't completed yet. But the grasses certainly are completed, and in Flora of North America, quackgrass is in the genus Elymus now. It used to be an Agropyron. They moved it from Agropyron to Elymus, or I should say the experts did. I think it's listed as Elytregia in the handout, which is an older name. But you're always going to have a problem, somewhat of a problem with names, scientific names, because of the updating that occurs. So,
yeah, like,
but that was the only one. So I think we can get started with the video now. Tiffany?
Okay, I'm going to share my screen and hopefully this works. If you do happen to notice anything with the sound, just type it in the chat and I'll see if I can troubleshoot.
Good morning. Here we are at Ada Hayden Park, north of Ames. We're going to be taking a look at mainly wetland areas and reconstructed prairie this morning. We're going to be looking at probably a mix of native and non-native. Again, the focus of this webinar is non-native species, but as we go along, we'll probably be pointing out some native ones as well. The idea, of course, is for you to be able to distinguish between the native and non-native species. So we're in a little bit of a wetland basin here, reconstructed wetland basin. And we'll start right here along the edge. I'm going to take a look at some things that we see right here. One of the species that you're going to see often in a wetland, of course, are smartweed.
yeah,
Plants right down through.
I think she was there even before we left.
Yeah, no, it sounds like she's been there for a couple of years.
I think she's just stepping up.
Hey, Liz, this is Pat Sauer. Could you guys mute yourself, please? Thanks.
Sorry.
And Tiffany, I don't have any sound. I'm not sure if anyone else is having.
I don't have any sound either. There was some sound at the start, but we lost it as we were starting to look at that first
I think
plant.
it was because somebody muted me by accident. I've unmuted myself, so let me start the video back up.
The little bristles on the top edge of it. And I can see some little bristles on these ochrea here. That puts it into a group that the next time I want to take a look at are the flowers, the tepals, which is a term that's used to describe petals and sepals that look alike. And I can see that these have little punctate glandular dots. That pretty much tells me that it's one of two species. It's either dotted smartweed, Persicaria punctata, or is pepper smartweed, Persicaria hydropiper. And you can look at the achenes, which are the fruits that would be inside these flowers, except that they're not really developed yet. Or what I often do is just take a leaf, put it in my mouth, chew it a little bit. Takes about maybe 30 seconds or so. And I'm not getting any kind of hot, peppery sensation there. That suggests to me that this is Persicaria punctata, dotted smartweed, because hydropiper, like its name suggests, pepper smartweed, when you chew on the leaf for a little while, you will start to feel a very sort of hot, like a hot pepper type of sensation. So probably Polygonum punctatum. Now this is a native species. Hydropiper is a native species as well, but they look somewhat similar to two non-native species. Hopefully we'll see those. There's lady's thumb, Persicaria maculata, and there's another one, Persicaria longicida. Those two are non-native species that look somewhat similar to this, have sort of the same good gestalt as this. They don't have those punctate glands though that we saw on the flowers. All right, that's the smartweed. Of course, another non-native one that we've already talked about, I think a few times, at least the first time out, and I think we probably saw some the second time too, is this plant, which you're always going to probably run across in a wetland basin or a wetland wet soil place environment. Reed canary grass. Here again, we see it with the flowers finishing up here. The leaves starting to dry up a little bit here. I mentioned this, I think, last time. You can usually depend on reed canary grass to have a fairly large ligule, this membranous structure right here. You can see that breaking up there quite a ways. The collar area is the area between the sheath and the blade. That collar area is a really light green coloration right through there. Pretty broad leaves as far as grass leaves go. Reed canary grass, which again, I think I've mentioned before, but just quick mentioning as well, that this is a native species to North America, but the cultivars that are widespread and established throughout North America, especially in Iowa, the cultivar is not native, of course, and that's the origin of the problems with it being an invasive species. Here's another weed. I think I mentioned this last time as well, but I pointed out this is giant ragweed, Ambrosia trifida. Pretty distinctive tri-lobed leaves here. This one can get really big. It's a really good example of an early successional ruderal or R-selected type of species. I've seen giant ragweed as tall as 10 to 12 feet tall in really rich soils. And up here we have a couple of willows. So we'll just mention those since we're looking at them here. This one looks like to me, when I take a look at the willows, and willows are challenging for sure. A couple of things we want to look at when we look at willows is, first of all, the coloration pattern on the top of the leaf versus the bottom of the leaf. So if that's pretty similar, as we see here, this is kind of a medium green tone on both the top and the bottom. That helps to push us towards black willow. Black willow is going to have sort of the same medium green coloration on both top and bottom surfaces of the leaf. They'll have a leaf that, again, is fairly, most willows are fairly long leaves, of course. The leaves are fairly long compared to their width. But we also do sometimes try to measure the length and the width, and then look at the length to width ratio and see just how much longer a leaf is than it is wide. That helps with sandbar willow, which is the next one we'll take a look at. But most likely, again, looking at this one, because of the coloration pattern and because of the length to width ratio here on these leaves, the amount of teeth that we see on the edge of this leaf, quite a few teeth. There's probably at least 15 teeth or so per linear inch there. This is probably Salix nigra, black willow. This would be young plants right here. Black willow grows into a tree, and be a very, very large tree. These would be young sapling size trees right now. The other one that is common, and you'll certainly come across in wetland areas, is this one right here. And you can see here, just looking at the leaves, that this one has much longer leaves compared to the width. So the length to width ratio on this one is much larger, probably up to maybe almost 20 times, 15 to 20 times longer than it is wide. This one too has pretty much the same sort of medium green coloration on both the bottom and the top, but because it's much more narrow, much longer, again, that length to width ratio is much larger. And now when we look at the number of teeth in about 1 inch of margin or so, there's very few teeth. There's probably about 5 or 6, maybe 7 teeth, little small teeth along the margin at least. So the teeth are very sparse and separated on this leaf compared to this leaf. This is sandbar willow, Salix interior or Salix exigua, a couple of the scientific names for it. This one is a shrub species that can grow into a small tree, but we most often see it as forming these dense shrub thickets on sandbars, along streams, along riparian areas. Sandbar willow. All right, then the last one we'll take a look at here along the margin here of the wetland is this one right here, just because it's here. This is a native species. This is blue flag in the iris family. And they can be creatively, kind of hate to break too much of this off, but we can just take a little piece of it here. The irises have what are called equitant leaves. Equitant means, it's a term that describes the situation we see here with the edges of the leaves are basically coming together down here face to face like this. What's actually happening here is that the leaf is folded over in a sense, and we can't really separate it, but the leaf would normally be like this, has folded over and has fused along here. So when we look at the leaf on either side, we're actually looking at the bottom of the leaf. Again, the leaf was like this, and then it folds over and fuses. So you're looking at the bottom side of the leaf. And because of that, again, these leaves, as I was showing, come together edge to edge like that. That's a real good characteristic vegetatively for the blue flag. Helps you to separate it from other plants like Sporganium, burrweed, or cattails, or other plants that have a similar looking large, sword-shaped leaf. And then lastly, we'll go back and take a look at the plants out here in the wetland, submergent and floating leaf plants. I'm venture into the muck here a little ways. So you can certainly see all of the really large leafy stuff right here. This plant here, this is a photomageton or a pondweed. The photomagetons are usually fairly difficult. It helps a lot to have these flowering structures. They're difficult in part because they'll have both floating leaves like this one and submersed leaves. Sometimes you have to look at the submersed leaves to separate them. This one is probably, just looking at its general appearance, it looks like it's Photomageton nodosus. And then, of course, there's a lot of little floating duckweed, tiny little plants here. These are in the group of plants that are the smallest of the flowering plants. That's little duckweed on the tip of my finger right there. That little tiny plant can produce a flower, tiny flower. But duckweeds aren't the smallest. There's another plant called Wolffia or watermeal that's even smaller than this and produces flowers, again, of course, that are smaller. Then out there a little bit further, we can see some of that light green material there. That's some type of filamentous algae. So the wetland basin here, probably constructed to help catch nutrients before they make their way down into the lake. Looks like it's probably doing a good job of that.
Okay, so we are going to pause the video at this point. And if anyone has any questions, go ahead and use the chat area. I am trying to help someone join the call. They're having some sound issues, so I'm trying to help someone behind the scenes. But anyone have any specific questions on management or the species? Or Tom, if you have any suggestions on management of some of these species. Oh, here's a question. Were the water species native or non-native?
So the smartweed species, maybe you're referring to. That's a correction I need to make. The smartweed I was looking at there, again, dotted smartweed is native. I was trying to separate it from a species called Persicaria hydropiper, pepper smartweed. Pepper smartweed is non-native. I misspoke when I said it was native. I was thinking of another similar one, hydropiper pepper. But hydropiper is non-native. It looks very similar, and this is the one that you're most likely going to confuse with dotted smartweed is Persicaria hydropiper. Then the other thing I guess I would quick just say is that again, this is just going back to scientific names. I think in the handout, the name Iris shrevii is used for blue flag. That's now in Florida, North America, that's Iris virginica is the scientific name used for it now.
Okay, here's another question from Joseph. What are some non-invasive willows, and are they similar to black and sandbar willows?
Some non-invasive is a question?
Correct. Correct.
Non-invasive willows. So native willows, I guess, is the question. What are some native species?
Right, yeah. What are some non-invasive willows, and are they similar to black and sandbar willows?
Well, there's three willows. Let me just put it this way. There's three willows that you're really likely to encounter, native species of willows that you could easily encounter in wet soil or wetland environments, riparian environments. The two that we saw there, black willow and sandbar willow, and then another one called peach leaf willow. Unfortunately, we did not see peach leaf willow. If we would have, I would have been able to show the importance of making that comparison between the top and lower surface of the leaves, because in peach leaf willow and in some other willows, I'd also throw, I guess, Salix discolor in there, which is, that's the That's another common shrubby species. But the thing I'm getting at is the top surface and bottom surface of the leaves have like two color tones. The top is going to be more of a medium green, and the bottom has more of a bluish green sort of tint to it, or a pale green, sort of it kind of comes from a glaucous type of surface on the bottom side of the leaf. But if you see that sort of bicolor, I guess I use the term bicolor leaf, the top and bottom surfaces are not exactly the same, or don't look very much the same. The bottom looks more light green or bluish green. Then that's going to again take you to another group in which Salix amygdaloides, which is the peach leaf willow, and Salix discolor. Those species are going to be found there. Peach leaf willow will grow into a tree. But the problem with these willows is that, and sometimes the keys start up by saying, is this a shrub or a tree? Well, that is an important distinction, because some willows stay as shrubs, other willows will grow into trees. But what's frustrating about that approach is that there's many times, like we saw this morning here along that wetland, we're seeing small versions, small shrub-sized versions of tree species. So black willow and peach leaf willow, you can run into them and they'll be the size of a shrub. They're just a very young tree, of course. So well, you really can't use that very well to distinguish which species you have. You have to use the leaves, that bicolor. You have to use the size, the length to width ratio, like I was talking about, the number of teeth. If you have the flowers, that's great, but so many times you don't have the flowers or fruits of willows. Willows are dioecious, meaning that the sexes are separate. There are female plants and there are male plants. And again, the reproduction is geared to early spring. So even by June almost, or certainly the rest of the growing season, you won't have flowers or fruits. So you're always going to be using the leaf characteristics. But yeah, those three. Now, are there some non-native species? Yes, there's definitely some non-native species of willows. I don't really ever see them as being very invasive. I've never encountered a situation where I would say, there was a problem with an invasive willow. I suppose it could happen somewhere, but I've not seen it. And let's see, one of probably the most common non-native willows. Well, there's of course the weeping willow. That one's usually planted in an urban area, so you don't see that out in nature very much. There's a couple of other ones that are non-native, but to be honest, I really don't see them very much at all. I usually see peach leaf willow, black willow, and sandbar. Those are the three willows I see the most. Now, if you're in a really high quality sedge meadow, or like Doolittle Prairie, good, really wet music prairie, you can run across meadow willow, which is a native species, Salix petiolaris. But I'm not sure if that answers your question. Let me know if it doesn't.
Okay. And we do have another question, which actually is related to my question, a question I was going to ask. So willows are used in stream bank stabilization programs, providing stability to minimize, to try and stabilize the soil, but also add roughness. So here's the question. Are the willows in this video used in stream bank restoration practices, even though they are considered weeds?
Well, I don't know if I can answer that question because I don't work in that area or that environment very much. But I certainly think sandbar willow has been used in that way, because I think sort of in river restoration projects, I think I've heard of people, just taking cuttings. You can take a cutting from sandbar willows and just pretty much stick them in the ground, and under the good conditions, they will root and start forming those dense thickets. I mean, and that's true. I mean, those sandbar willows in particular, they form really dense thickets at some point. they can get pretty abundant and dense thickets, which are certainly going to hold that soil pretty well. There's going to be a massive roots there below that thicket. So, and it's the natural environment for it, certainly. And probably a good number of at least bird species and maybe even some medium-sized mammals obviously use those thickets as well for nesting and for cover. So that one's probably the most useful, I would think, in terms of holding soil. Black willow and peachleaf willow, again, they will grow into more of a tree. And a tree then, again, is not going to have nearly the multiple stems, the massive number of stems and the associated root mass that can develop under a dense thicket of shrubs. By convention, sort of the difference between a tree and a shrub, of course, is a tree is typically a woody plant that develops just a single stem. Maybe there can be a couple more, like in basswood, and will grow into much larger size. We might say at least over 20 feet tall, whereas shrubs are woody plants that form they grow as a multiple stem plant. A single plant, a single individual will have many stems coming from the same root system, and typically they don't get nearly as large. Obviously, their stems are smaller in diameter, and their height's usually less than 20 feet.
Okay, so are there any preferred times of year to harvest if you're going to do a stream bank stabilization project? And there are willows, and it sounds like the preferred willow is the sandbar willow. Is there a preferred time of year or to harvest them, or can you harvest them anytime, whether they're dormant or not?
I don't have experience with that myself. I've never done that. I think what I've heard about or heard people talk about it, it seems like they, pretty much any time during the growing season, it seems like might work.
Okay. All right. So, all right. Thank you, Tom. So, Tiffany, I think we're ready for the next video.
Okay, let me get started up here for you.
Let's take a look at some non-native grasses that are often problematic in prairie plantings. First one, and probably the most common one, and probably often one of the most difficult ones to deal with, is smooth brome, Bromus inermis. That's this plant right here. Again, this is at the end of July, and so we're seeing these are non-native cool season grasses, and so they're pretty much done flowering and they're starting to die back. But here we can see some good examples. Brome will have pretty large spikelets where the flowers are. But probably the most distinguishing characteristic, of course, for the bromes is vegetatively. When you look at the leaves, remember that a leaf in a grass is attached at a node. This is a node right here. The first part of that leaf forms a sheath that wraps around the stem. And then at the top of the sheath, right up here, there's this, again, this collar structure. It's the division between the sheath and the blade, the photosynthetic blade. In brome, this sheath is fused so that it forms a solid piece of tissue, a solid piece of tissue that, again, wraps around the stem. That's something that you can see with a hand lens. Sometimes you can see it, if you look real close. What you'll see here as I pull this back is the sheath is split, forms kind of a V structure, but then at the bottom of that V, that tissue is completely fused. Other grasses that have what are called open sheath, this is called a closed sheath. An open sheath will have a sheath that the sheath overlaps like this, so the edges are not fused together. In brome, they're fused together like this. Those edges are fused together. In an open sheath, they're not fused, they overlap like this. So when you pull the sheath apart, an open sheath easily separates without any tearing of any tissue. A closed sheath, like brome has, when you pull down on it, you can force it to come apart, but you'll be tearing it. So that closed sheath is a really important characteristic for any of the bromes. Vegetatively, If you see it has a closed sheath, and you're in a upland environment, non-wet type of environment, pretty good chance you're looking at a brome. The only other species of grass that has a closed sheath that you probably encounter in Iowa is Glyceria, which is more of a wet soil grass. So the closed sheath, the ligule is a small little membrane. Now we can't see the leaves very well here. Maybe if we find a decent leaf here. Sometimes on brome, yeah, you can kind of see it right here. In the light right here, there's sort of either an M or a W crinkled. It's kind of hard to see unless you're looking at it right in the light, but that M or W, depending upon which way you're holding it, is another kind of good characteristic that some people like to use to help distinguish smooth brome. It's not always present on all the leaves, though. That closed sheath is better. And of course, just becoming familiar with the large spikelets that form the flowers, where the flowers are. Brome is a really common species, forage grass. It's widespread. Almost every prairie, every reconstruction, I know probably has a problem with smooth brome, unless the reconstruction went into an ag field, an old cornfield or bean field. So getting rid of and controlling smooth brome is always a problem that prairie managers have. A couple other grasses here, just real quick. These are native grasses. Here's switchgrass. Switchgrass, vegetatively, which is a native species, of course. If Pat can zoom in here on get this in the light right, you see this dense patch of hairs at the base of the blade. Looking at the blade here again and coming down towards the bottom of the blade again, right above the collar, there's a dense patch of white little hairs there. That's a really good characteristic for switchgrass. And sort of like wheat canary grass, again, that collar on switchgrass is a very distinctive, light color there. The collar area again between the blade and the sheath. Switchgrass has tiny little spikelets that have just a single flower in them, and they always have a very large branching type of structure up here. Again, with these tiny little spikelets. These are the spikelets right here, these little bead-like or round things that have a single flower in them. Here's actually some flowers right here. You can see the stigmas, the feathery stigmas, and the stamens are both protruding from those flowers right there. Proof that grasses do have flowers. And then the other one right over here, of course, this is big blue stem. Vegetatively, when we look at big blue stem, at this stage, it does have a lot of bluish glaucous kind of coloration often on the stem, especially around the nodes. Here again is a node where a leaf is attached. You can kind of wipe that off. That term here is glaucous, for that kind of bluish white waxy covering that I've just wiped off there. Here's another one right here at this node. And this is how it gets its name. And then the blue stem from innes, we look at the ligule, which again is this membranous structure right here at the base of the blade at the top of the sheath. Here again, this is a sheath. This is an open sheath. And then the ligule is this membranous structure right here. In big blue stem, that ligule is nothing very significant. It's somewhat inconspicuous. It's there if you look for it. In Indian grass, if we find some Indian grass, we'll look at that. The ligule is much more conspicuous, several times taller than what we see there, and more stiff. Big blue stem. All right, now we're going to move across the trail here to look at a couple other non-native species. The first one I'll pick on is this one right here. This one's pretty easy to identify when it's in flower. It has this really just dense, thick, crowded mass of inflorescence here of tiny little spikelets. There's lots of spikelets in here. Remember that grass flowers are always arranged in these little tiny inflorescences called spikelets. This is a large group of those spikelets. There's a whole bunch of spikelets crowded together in here, and that's what forms this sort of thick, massive column right here. So Timothy is characterized by that. Then sometimes, I'll see if I can pull up enough over here to show you. Sometimes vegetatively, I'm not sure I can get enough of it up. Yeah, I did. You have to kind of pull up the whole stem, but look at the base of this stem here. You see a little large, or not large, but very clearly an enlarged little bulb-like structure right here. Timothy always has these little bulb-like structures at the base of the stems. Sometimes you can just kind of reach down in there and dig into the ground a little bit and feel that round little bulb. It's a bulb-like structure, at least. So that's Timothy, Phleum pratense. Phleum pratense is another pretty common forage grass introduced for pasture and hay. It doesn't really become too aggressive, though. I don't see large populations of it generally, but it is a cool season grass, and so has that same problem that other cool season grasses have in terms of competing with their native species. And here's another one right here. This one is a little bit more aggressive and can be more of a problem species. And probably the best way, again, to recognize this one is when it is in flower and has its spikelets here. This is a quack grass. Now it's used to be Agropyron repens. Now it is Elamus repens, moved to a new genus. So quackgrass has these inflorescences that are pretty distinctive. These spikelets here, here's a spikelet, here's a spikelet. You can see the spikelets are arranged on opposite sides of the stem, kind of slight distance apart, a few millimeters apart. It forms this pretty distinctive flowering structure. Each of these spikelets here, again, has several flowers in it. Quackgrass is very stoloniferous and rhizomatous and will form sort of a clone, become somewhat of a problem because of that. And another thing on quackgrass vegetatively, again, we're seeing it at the end of its peak, so the leaves are kind of dying back, but this will be kind of hard to see with the camera, but right here again where the blade comes down and meets the sheath, right in the collar area, in that collar area, at the bottom of the blade are two little auricles, is what the term is. They're little slender projections that come off the base of the leaf, and I kind of, if this is the stem of the plant, the blade comes down, these little auricles kind of wrap around and project on the other side of the stem. They're very easy to see with a hand lens, but quackgrass leaves will always have those. So it's little auricles that project off the bottom of the blade and kind of wrap around on the opposite side of the stem. Quackgrass. Well, I'd like to show you a couple species that are.
Okay, so we'll open it up for any questions or discussion on the species that Tom presented, quackgrass, along with switchgrass, and I'm forgetting a few of the others.
Smooth brome,
Yes.
smooth brome and Timothy, and quackgrass were the non-native. The invasive ones, but particularly against smooth brome and quackgrass are invasive.
So what are the best recommended management techniques?
Well, for smooth brome, it's been very well studied, and I think quackgrass would go along and fit into the same category since it's a cool season grass. It's doing kind of the same thing as brome is doing. It just hasn't been studied as specifically as smooth brome because there's a lot more smooth brome. But what we've seen, and I've done my own research in this area, is that a properly timed late spring fire, and by late spring fire I mean, by late spring fire I mean mainly first part of May, probably even I burn as late as the third week of May, but you're trying to hit the brome with fire at the time when it's most susceptible to the stress of being top killed by the fire. And research has shown when it's starting to produce its inflorescence, when it's in what's called the boot stage, the grasses will start to produce an inflorescence before you see it. And it kind of emerges in from the top of the grass plant as kind of leaves uncurl around it. And that inflorescence then comes out of the top of the plant. But it's beginning to form that before you actually see it there. When it's in that boot stage, that's when it is pretty susceptible to stress, caused by top killing. So whether if you top kill it by mowing it, or if you top kill it by fire, either one of those would work. Fire is, a little easier to maybe cover a larger area, and fire will, of course, top kill it right down to the ground too. It's been shown that really has a dramatic effect on the brome. It can really lower the number of grass stems, the number of tillers that are present, the amount of biomass. And when you have a spring burn like that combined with a drought, as we've had the last couple of years, the effect can even be more dramatic. I actually purposely burned quite a few areas that I had to manage here at my farm that have smooth brome, burned them as late as I could because I anticipated it was going to be a dry year and wanted to get that effect. It's an interaction between the drought and the burn. So fire can work very well. Now, will you completely get rid of the brome? Certainly not with one burn, but you can really weaken it quite a bit. And, that's a step in the right direction, of course. The other thing that's important to realize here is that by burning it at that time, the brome has been growing, for at least 4 weeks or so. And so when it gets top killed by the fire, it's losing a lot of investment that it's already made in that plant. Whereas the native grasses, if there are native grasses in there, in the grassland or prairie, they're just beginning to emerge about the first part of May. And so what will happen is that the burn at that time kind of is really inviting and helps to open up the environment to the native grasses, makes it more sunny, warms up the soil. At the same time, it's top killing the brome. The brome will try to grow back from the root system because it's a perennial. Fire's not going to kill the roots. You're going to weaken it. But as it begins to grow back from the root system, now it's growing in a much different environment than it did 4 weeks earlier when it was the only thing growing. Now it's coming into an environment where native grasses are growing. And the competition then between native grasses and the brome is going to add yet a third stress factor on that brome. And again, numerous research papers are out there that show this. Again, some of my own work has shown it. The brome can be reduced by quite a bit. If you were to do a couple of burns in a couple of years in May, and you had, again, native species in there to fill the gap as that brome kind of goes down, I think you'd see a big improvement. The other thing you can do, of course, with any grass that's a problem is use an herbicide. And again, based on research I've been doing lately with reed canary grass, I would suggest clethodim. Clethodim is a grass-specific herbicide. It won't have any effect on the forbs, which is good if you've got prairie forbs there. The only difficulty you'll have, of course, is it'll kill any grass. It doesn't distinguish between the native and the non-native species. So you'll have to figure out a way to minimize the damage to non-target grasses. And the way to do that basically is to try to get some kind of difference between their growth. The way that I would suggest is, if you were to use clethodim really early in the spring, when there's only brome growing and Kentucky bluegrass, none of the native grasses have come up yet, then you'd have that separation. Or you can also maybe get some separation late in the fall as well, because the native grasses will usually senesce and become dormant at the end of the growing season. Whereas again, the non-native grasses can continue to grow and continue to be green, especially as it gets into the cooler months of October and November. You get separation there again, and then you can spray at those times and be pretty assured that you're only going to get this, the only thing will be affected will be the non-native grass.
Okay.
Those are a couple of things that could work.
Okay. All right. Thank you. I don't see any other questions. So Tiffany, if you could continue the video, please, that would be great.
Native and often used and found, of course, in native prairies. They're supposed to be in native prairies. But I would caution people about probably planting these species, or at least, if you are going to include them in a seed mix, make sure that the seed rate is really low. You don't need very many of these, because both of these species we're going to talk about here are somewhat aggressive and become a real problem in prairies. The first one is cup plant, Silphium perfoliatum. So it's related to compass plant. It's related to rosinweed, the same genus. Has very similar flowers, of course. It is a species we tend to find in a bit damper soils, so in swales or low-lying areas of prairies. It's a very large, robust plant, as you can see here, and you've probably seen in your own prairies. It has a very large, thick, somewhat square stem. The characteristic, of course, is that the leaves are fused together at the base. So you have opposite leaves here that are attached at a node. But these bases of these leaves are completely fused to each other, so that it forms one massive leaf structure here. The stem seems to perfoliate or go through the leaf. Basically, it does. That's the source of its name. So it's an easy plant, of course, to recognize with these large cups, but it is a really difficult species to start controlling when you get too much of it. Probably one strategy, we can talk about some more of this, I guess, during the webinar, but this and sawtooth sunflower, which is this one right here, again, you're going to have a strategy that, of course, sort of selectively targets these species as much as possible. Because usually when you have this problem, you've got a prairie planting, you've got lots of other good prairie species that you want. You have to try to at least reduce the amount of these. The other one, as I mentioned, is sawtooth sunflower. That's this plant right here. It's a pretty easy one to recognize. Got a couple of good stems here. So the leaves are generally opposite, like in most sunflowers. There will be some teeth, not necessarily very large, but the thing that really stands out on sawtooth sunflower is the stem, again, that's glabrous. It doesn't have any hairs on it, and it has this glaucous, bluish-white, waxy covering on the stem that, again, when you use your fingers, you can wipe it off. It will have substantial size to it. It can get pretty tall, about just as tall as the cup plant here, and can form dense clones. Again, most sunflowers have rhizomes that they grow below ground that allows them to reproduce vegetatively, and you start getting these dense patches. So again, you don't want very much of this. It can overtake a prairie and reduce the diversity because it just gets too dense. We'll talk more about how to control these during the webinar. Well, we're standing along this boat launch to Ada Hayden Lake right here.
You want me to stop the video or keep going?
You can keep going.
Okay.
We're in a disturbed area here where this gravel meets in with vegetation over here. So we're just kind of going to walk along this edge and point out, the various weedy things that we're seeing here. So let's start with plantain. Plantains are obviously something you're probably familiar with. This is Plantago down here. There is a couple non-native species. This one here is Plantago major. It's non-native, weedy species. Most of the plantains are kind of weedy in general, even the native species. But this one looks most like a native species called Rugel's plantain. And the way to tell Rugel's plantain, which is the native one, from common plantain, which is a non-native one, is to look at the base of the plant down here, the base of these leaves, and we don't see any red coloration in through here at all. Rugel's plantain, the native version of this, will have dark red coloration, at least along the bottom parts of these petioles of these basal leaves. There'll be at least a half centimeter or centimeter or so of red coloration down and through here. Very distinctive, very easy to see that. You don't need to have the flowers. You just need to be able to see the leaves. So for what it's worth, again, Rugel's plantain native, common plantain not. All right, then another one that we have right here in flower. This is flower of an hour or Hibiscus trinonum. It's in the mallow family. Beautiful flower there. The leaves are a little bit eaten up, I think, by some Japanese beetles we've been seeing here. But here's a look at the leaves are somewhat divided into leaflets, it looks like here. Here's a leaflet here, and here's a leaflet, and the leaflets themselves are lobed. Usually there's at least 3 of them, so we're missing a leaflet on this side. Hibiscus trinonum, or flower of an hour, right here. Another common, we mentioned this I think last month, but here's common ragweed, Ambrosia artemisifolia. Here's some sweet clover right here. We're seeing again, pretty much everything we see down through here is going to be a weedy species. Can't tell which species, of course, but sweet clover, Melilotus. This plant right here, that's kind of spread out right here, has this thicker stem, kind of prostrate. Here's some of the leaves right here. This is common purslane. It's actually a species that has can photosynthesis, has the same photosynthetic pathway as cactus. So this one will really handle the heat and dryness pretty well. All right, here is a little weedy species, a native species though, we haven't seen yet. This is called Virginia copperleaf. Virginia copperleaf, Acalypha virginica. So there's a couple of species that look like this. This is Virginia copperleaf, and then there's another species, Acalypha rambodia. The difference between those 2 species usually is just to look at the leaves here and the relative length of the petiole. When the petiole, this portion right here, relatively speaking, is less than the length of it is less than the length of the blade. The blade is, of course, all of this right here. That's all of the blade. You're looking at virginica. If the petiole was much longer relative to the blade, that would be rambodia. Rambodia is more of a floodplain forest species, where virginica is a little bit more of a weedy ruderal species. All right, then let's see. Here's one that you've probably seen, in farm fields. So this is velvet leaf, or otherwise known as buttonweed, Abutilon theophrasti. It's in the mallow family as well, the same family as the flower of an hour. Pretty distinctive, there's heart-shaped, soft leaves on buttonweed, or velvet leaf. All right, then let's see. Here's a common giant ragweed. Excuse me, giant ragweed, not common. Giant ragweed. We saw that earlier. Some more sweet clover here. Here is one that we've seen before as well. This is prickly lettuce, Lactuca cereola. Again, this one has very divided leaves. It has prickles, or these little sharp little hair structures. You kind of see them on the stem through here. Usually has some of those prickles on the bottom of the midrib. You can see them really well right there, I think. Right through here. I'll hold that in the light just right. Those prickles. Usually some prickles along the margins of the leaves. And the leaves, again, somewhat always, they kind of come off and then they kind of turn, so that rather than being like this, they tend to be more like that. You see how that's occurring here. The leaves are kind of turning and oriented so that the edges of the leaves are up and down. Prickly lettuce, Lactuca cereola. And let's see, here's some yellow foxtail right here. I haven't seen any foxtails yet. So Soteria is the genus. Yellow foxtail this is a really good example of it. It has this reddish coloration at the base of the tillers of the stems. Has somewhat flattened stems. See how flat this looks here? Compressed, so to speak. And we look at the leaves at the base of the blade again. This is the sheath. This is the blade. Right here at the base of the blade, at the top of the sheath, a lot of kind of long, straggly looking hairs, usually present right through there. The ligule on the foxtails in this structure that's right at the junction of the sheath and the blade is a short little fringe of hairs. So ligules can be either membrane structure or they can be a little row of hair-like structures. All right, so yellow foxtail, Soteria glauca, is the scientific name for that one. All right, moving up the slope, here's some crown vetch. We've talked about crown vetch already. Here's some small plants in through here. That's some sweet clover. This is the crown vetch right here. It's the large number of leaflets on each leaf. Dandelion right here. And here's some Canada thistle. This one, there's one up further up here that has a little bit better flower head on it right here. So these are some flowers starting to form here. Susium arvensi, Canada thistle. This is a real difficult species often to control and invasive, certainly. And I think there's a couple more. Here's Canada thistle right here. Let's take a look at the bottom side of it, and you see that it's slightly a little bit lighter, but it's still kind of a light medium green. When we look at this thistle, we can see that the bottom side is way lighter. This has got all kinds of short little dense hairs forming that white on the bottom side of it. Canada thistle doesn't have that at all. It can have a few hairs, but they're not dense enough and thick enough and carpet-like to the extent that we see here. So this is a native thistle. Again, the whiteness on the bottom side tells us it's a native thistle. This is Susium discolor, field thistle. So a good thistle to have. And I think we have one more to look at right here. This is giant foxtail. Right here, Soteria faberi. So the foxtail heads are pretty distinctive. You often can recognize foxtails just again by just the dense mass of spikelets in here, and then all of those little bristles that are coming off, intermixed with those spikelets. Those are little bristles that are mixed in with the spikelets there. Gives it that bristly look, hence the name foxtail. Another thing, if you don't have the heads, one thing about foxtails, especially giant foxtail and green foxtail, now yellow foxtail doesn't have this, but if you pull the sheath back, so you can see the sheath right here. Here again is the blade, here's the sheath. And then you'll need a hand lens probably to see this, but if you look at the margins of this sheath along the edges, remember this is an open sheath. So when I pulled the sheath back, what happened is the sheath just opened up. Now I'm looking along these margins of the sheath. Look along those margins, there'll be a row of little tiny hairs. Be kind of hard to see probably with the camera, but I can see them with the hand lens. A row of just along the edge of that sheath margin, there's a row of tiny hairs. The foxtails have that, so they have those hairs along the margin of the sheath. That will be true for giant foxtail and for green foxtail. Then to separate giant and green, what I always do is just look at the surface of these leaves. Hold it up to the light, you can kind of see the surface of these leaves. Maybe you can see that on the camera, but there's hairs on the surface of the leaf. Pretty dense layer of hairs on the surface of the leaf. Those hairs tell you that it's giant foxtail. Green foxtail would be glabrous. The surface of the leaf would be without any hairs at all. And usually on green foxtail, the flowering head isn't quite so large, and it doesn't usually droop as much as giant foxtail. Green foxtail, usually it's a little bit shorter and it usually stands up more. Green foxtail, giant foxtail, yellow foxtail, these are all non-native warm season grasses and annual grasses that, because again, they're warm season grasses, they're flowering now towards the end of summer during the warm season, warm part of the summer. But they're annual grasses. So once the perennial prairie grasses get established, you can have a lot of these, of course, it'd be somewhat of a problem in the early stages of a prairie planting. But as the perennial warm season grasses get established, start competing and start shading out these grasses, then these weedy foxtail species will usually fade away. Here we are along the...
Okay. Any questions at all on the species of plants that Tom just presented? Don't forget, you can unmute yourself or you can use the chat box for any questions.
That was kind of a smorgasbord of weeds there.
Any unique, oh, here we go. Can you discuss a little bit more about controlling Canada thistle?
Canada thistle, I think we did talk about that previously a little bit. That's going to be a challenge, and it's going to take multiple approaches, multiple factors, I think, to have success there. From my own experience, I can at least talk a little bit from that vantage point. I've had pretty good luck by first always trying to make sure that it never goes to seed, because I don't want more of that Canada thistle spreading to new areas or to new plantings. When you do a planting, you're in an early successional stage. A planting is an early successional plant community, and so that's a time when weedy species can disperse in there and become a problem. So again, just making sure that if you have any, that you at least don't let it spread. You do that by mowing it. Mowing it can also, of course, cause some stress as well. It's going to stress the plants out. Make sure that you mow it when it's just beginning to flower, just beginning to see some of that purple. If you're starting to see white and fluffy stuff, you're too late. And I think it would probably be a good idea maybe not to mow it then, because you're just going to help it spread. But again, what research has suggested is that if you mow it, to stress it during the middle part of the summer or early summer, and that's also going to again help prevent any kind of seed being formed. So you do two things. And then the ideal time to spray it, according to the research I've read, is in the fall. As those plants regrow, which they will because they're a perennial plant, you target a spraying for probably October or so. Idea is to spray it again when it's still physiologically active and growing. You don't want to wait too long, maybe even late September. You kind of have to gauge it by what it looks like, but by spraying it at the end of the growing season, basically there before it senesces, it will certainly pick up the herbicide well. And I think the idea is that it seems to have maybe an interaction effect, the herbicide and its action against the plant, is going to cause stress. That combined with the weakening of the plants, the weakening of the root system because of that, combined with wintertime and cold temperatures, the root systems are just less able to survive the cold winter soils, and you get a better reduction rate, a better kill rate by spraying it then. So from what I've read, and that's how I've managed it here too when I've had to deal with it. That seems to work pretty well. The herbicide to use there, well, there's the trademark name that I use is Transline. I think that is. It's always hard to remember all the chemicals, the active ingredients here, but I think that's clopyralid is the active ingredient there. That, or Milestone probably would be another good option, perhaps, because I think that combines some clopyralid with some other things. So that would be what I would try.
Okay. And we have another question. Can you talk a bit about controlling cup plant and sawtooth sunflower?
Yes, I made a reference to doing that. So those are likely going to be a little bit harder, of course. You don't want to, you don't necessarily want to kill them completely, like you do Canada thistle, I guess. And the other thing about Canada thistle is often Canada thistle, because it's so clonal, it really grows vegetatively, and so you will get these sort of dense patches that you can pretty much just mow those, and you'll just be mowing Canada thistle for the most part. For the other two species, and I've got both of them where I live here, and I've been working on trying to do something to cut them back, to reduce them for a number of years. And you have to just be more selective unless you're going to just completely sort of start all over again. If it's not that bad, you don't really want to do that, of course. So what I do is just go out and mow those areas, try to just target mow those areas where the cut plant is the most, or sawtooth sunflower. The sawtooth sunflower,
Okay, Tiffany, I am not, the video has stopped.
Yeah, I think there's the connection with Tom has cut out.
Okay, well, maybe what we will do is, I think, just continue playing the video, and perhaps Tom can back out and rejoin us. So why don't we just continue playing the video, Tiffany?
Okay, I will start the video back up.
I'm not getting any audio.
North America. This one is the narrow leaf cattail. You can see again the leaves are really narrow. I don't have a broadleaf one here, but The broadleaf cattail will have leaves that are probably at least 2.5 times larger or wider than what these are here. And the flowering heads on narrowleaf cattail are much different from the broadleaf cattail as well. For one thing, the female part of the inflorescence down here, these are all female flowers. Then the male flowers, which are gone now because the pollen has already been dispersed, but the male flowers were up here. You can see a green band right here. This did not have any flowers. The male flowers started right here, and they were in this area right here. So the fact that there's a separation between where the male flowers and the bottom of the male flowers, then there's this green separation without any flowers. And then at the top of the female flowers right here, that separation is another good characteristic of narrowleaf. So narrowleaf is probably best described as a cryptic species because it's not completely certain what its native origin is. Some recent work has suggested, genetic work has suggested that it is probably native to North America. And Flora of Iowa Committee or Flora of Iowa Working Group has looked at the information, looked at the research, and we've decided to probably consider, it's probably best to consider it native to Iowa as well. But it's not completely clear. Now there is a hybrid species, Typha glauca, which is a hybrid between the narrowleaf, this species, and the broadleaf. The hybrid, like most hybrids, usually exhibits more vigor, a little bit more tendency to become a greedy, aggressive species. I would say that, Angustifolia, the narrowleaf, and Latifolia, the broadleaf, when they're pure, those lines aren't too bad, but the hybrid can be more of a problem. The hybrid's going to exhibit just an intermediate level of characteristics. So the leaves will be intermediate between the really narrow leaves of Angustifolia and the broader leaves of Latifolia. The flowering spikes, heads will be a little bit thicker. There'll be less separation here. So it just basically exhibits just a blending of the characteristics and an intermediate stage between the two. And it also usually grows much taller and is more robust. Let's take a look at some woody species, non-native, somewhat invasive woody species, and this one right here would be.
Do we have Tom back, Pat, or is he
We
still?
do not. We do not have Tom back. I'm working on it behind the scenes, so I would say just keep rolling the video. Thanks.
Okay.
May.
No.
A tree that's certainly at the top of my list. I've seen many places that have a problem with Siberian elm. Almost pumila is the scientific name. This is it right here in shrub or sapling size form. It will again grow, of course, into a very large tree. So it has the typical elm leaves, as you can kind of see here, with the very strong pinnate venation. But the leaves are way much smaller than the leaves of American elm or red elm. Now, it can be a little bit more difficult when you're looking at a full-size tree and you're looking at sun leaves and shade leaves. But in general, again, if you're, overall, look at all the leaves in general, and if the elm leaves are considerably smaller than, I would say probably in the 2-inch, 2 to 2.5 inch length size range. If leaves are not much bigger than 2.5 inches long, then Siberian elm is probably what you've got. Both American elm and red elm, these are usually 3 to 4 inches long. Siberian elm. Right next to it here, just for fun, let's take a look at some blooming prairie plants. Here's some butterfly milkweed, still hanging on. Some nice blooms there. So butterfly milkweed is quite different from the other milkweeds, of course, in that the leaves are alternate. Just get a piece of this branch off. The leaves are alternate rather than opposite, like most milkweeds. The leaves are pretty crowded along the stem. There's lots of leaves here. And it doesn't have any milky sap. So butterfly milkweed kind of stands out as kind of unique among the milkweeds in that regard. But I would say it's probably one of the most striking and most beautiful of the milkweeds, and it's in flower. And another one that's flying here in this prairie planting is this ironweed back here. This is Vernonia. Looks like it is Vernonia baldwinii, Baldwin's ironweed, which is the most common of the four species of ironweed that we have in Iowa. So it has flowers that are kind of similar to the flowers in a blazing star, in that when we look at the head of flowers here, these are all disc flowers. Again, if you go back and think about Asteraceae, which is what this plant is in, the family it's in, Asteraceae can have ray flowers, can have disc flowers. We're going to have both ray and disc flowers, which is what you see when you look at a sunflower, for example. But when you're looking at a blazing star or an ironweed, you're looking at just disc flowers. So the way to separate some of these ironweeds is some of the leaf characteristics, whether there's hairs or not, the type of solid tooth, so the type of teeth along the margins of the leaves, the size of those teeth. And then often also some flower characteristics are useful for separating, for example, Vernonia mazurica and Vernonia gigantea from this species here, Vernonia baldwinii.
Okay, Tiffany, you can probably stop the video at this point. Tom was able to rejoin us. And Tom, if you could talk a bit about cattails and cattail management, that would be great.
Okay, so you went through the cattails, right? So the cattails presents another difficult situation in trying to understand whether, especially narrowleaf cattail, is native or not. And I think I kind of alluded to that a little bit there, but long story short, basically is there is sort of this controversy. It's not completely known whether narrowleaf Typha angustifolia is truly native to, certainly not completely known for sure if it's native to North America. There's been this discussion, there's been work on that. The latest thing that I've seen, and I always try to go with the science, of course, and look at the latest work that's been done. This is what was done for the revision of the Flora of Iowa, is that it looks like the latest evidence is suggesting that it is native to North America. And we think it was probably that because that, if that's true, then it was probably also native to Iowa. So both species of cattail that you might encounter, at least that's the supposition that most of us are making right now, either the two species, broadleaf or narrowleaf, are or should be considered to be native to the state. So in that sense, you know, they are okay to have, of course. Question is, you know, do you have too much? And there's also the possibility of having the hybrid. You know, the hybrid is a hybrid between the two species that's going to naturally form, and it's going to be naturally be present. Typha glauca is the name of that. And the hybrid, like a hybrid does, it combines characteristics from both species. So basically the things that you're looking at, the things I described there, are intermediate for it. And like many hybrids, and again, it has this sort of hybrid vigor, so it is usually more vigorous than either of the two parent species. And you'll often see, I've seen this at Ingaldinger Marsh, I believe, there's a hybrid clone or an area where there's some that is visibly quite a bit larger and taller than either of the other two species. So the question is, you know, how much of it you should have, I guess, and whether you have too much. You know, cattails are going to be somewhat naturally able to sort of take over and dominate an area, again, with their clonal growth and often just by their pure size. I haven't worked in this area very much, of course. I have cattails on my pond. They stay right along the margin where the water is shallow. I think probably, from what I know, which is not a lot, but if you have a cattail problem per se, in that you think you have too much, I know that from what I've read, it's probably going to help if you had some way of water management. Now, well, maybe you don't, but if you have a situation where you can control water levels, you can draw down or you can raise levels. That will help somewhat, because you can use water level again to help push back on them some. And to some extent, you can use water level to select either of the two. Typha angustifolia likes to grow in deeper water. Typha latifolia seems to do a little bit better in more shallow areas. We see that for sure. Other than that,
oh,
yeah.
Tom, I was going to say for stormwater management for wet ponds or retention ponds that have a permanent pool of water, you can correct me if I'm wrong on this. What I recommend to people is typically, yes, you will see cattails growing along the edges of the basin because they like their feet wet. But if you see cattails growing in the middle of a stormwater basin, more than likely that basin has received way too much sediment and it's probably time to do some serious dredging. Would you agree with that comment?
That sounds correct to me, because if there's cattails in the middle of it, it sounds like it's not as deep as it probably should be. Because yeah, there's definitely a limit to what cattails can grow in, and I would say, based on what I've seen, a couple feet is about it, maybe 2.5 feet at the most. And you would assume that there's been some sedimentation in or something that is making it possible for cattails to grow there.
Okay.
Right.
One of our participants, because we had lost your connection right when you were beginning to discuss this, if you could talk about the control of cup plant and sawtooth sun.
Well, yes. So what I was getting to was what I try to do is it's a real selective, targeted kind of thing as much as possible. Because what I'm dealing with, and I think probably most people are, I've got too much of it in a planting. And I can tell you why too. And the reason why I have too much is because I made the serious mistake of using a bulk seeding, which I never will do again. That was my mistake way back in 2004. And that bulk seeding had way more cut plant and sawtooth sunflower seeds in it than what I wanted, of course. But no, now I have to deal with it. So what I try and do is, as I said, I mow it as selectively as I can, often with a tractor mower, because I have enough of it. But then I come back in when it's regrowing, and I'll then use my steel brush cutter. And when it's only about, it's regrown enough so you can clearly see what it is. It's maybe not even a foot tall yet. I'm gonna come back in with a hand mower, and now selectively mow just those plants. I've tried that for a number of years, just thinking that will weaken it, and some of those plants will die out. I think I've reduced it some doing that. I basically still working on it though, and this time what I'm going to try and do, in fact, I'm probably going to be out this afternoon doing this on a prairie out in front of my house, is using an herbicide, because the mowing, this didn't cause enough stress. The plants were able to survive both of those, the first mowing and then the second mowing. Now they kind of disappeared for a while, but I think they were able to come back. So what I'm going to do this time is use the spray and just use a backpack sprayer and just, again, selectively spray those clumps. That kind of thing is only really possible in fairly small areas. I'm dealing with a half-acre, prairie planting. So if you had a larger area than that, and I think if you really had a severe problem with it, to be honest, I think I would consider starting over or something, because it's going to be hard to control that stuff.
Okay, thank you, Tom. Well, I think, Tiffany, we can continue with the video.
Okay, here we go. The last few minutes.
Trail, a honey locust. The honey locust is a native species, of course. It really was probably most predominant on floodplain environments, but now it's become really quite invasive, especially in pastures. It can be pretty much of a problem in reconstructed prairies. So it's a species we often have to control. Honey locust usually has very large thorns. This species, this specimen right here, it doesn't have any thorns anywhere, so either it hasn't developed them yet, if it's a young plant, or it's possible it's a thornless variety, which has been developed horticulturally to provide shade. The leaves on honey locust are either once or twice compound. So you pull off a leaf. Let me just check this to be sure. Yeah, so when you're trying to decide where a leaf begins and where a leaf ends, what we like to look for is the axil of the leaf and look for a bud. In honey locust, the buds are somewhat concealed, so it's a little bit hard to find them. But there's a bud right down in here. That means that then all of this is a leaf. And since we've got leaflets that are arranged on an axis that is coming off the main axis, this is twice compound. So this is the primary rachis right here, and then the secondary rachis comes off of it, and that's where the leaflets are attached. So this is twice compound. Honey locusts are either once or twice compound. Usually you'll see both once and twice compound leaves on the same tree, same plant. Lots of small leaflets, as you see here. But of course, the characteristic that you always like to use to confirm it are the large thorns. The thorns on honey locusts are modified branches. That means that they're going to come off of the plant, again, in the location of where a bud would be. A bud is what produces the lateral growth, produces branches that then produce more leaves. And in the honey locust, again, that branch becomes modified into a sharp, strong, pointy thing we call a thorn. So in honey locust, the thorns are modified branches. Sharp, pointy things on other plants are other kinds of modifications. So, for example, if you look at a raspberry plant, the sharp, pointy little things there, they're not nearly as big as a thorn, of course, but they're sharp and they're pointy. They're made to protect the plant, of course. Those are modified hairs. And then on black locust, for example, a relative of this in the same family, the sharp, pointy things there are called spines because those are modified leaves. Point being, again, is that structures made to protect the plant can either be modified branches, a thorn, modified leaves, a spine, or modified hairs, a prickle.
Okay, that is the end of our video. Tom, did you want to talk about any management? And if you have any questions, you could unmute yourself or add them in the chat.
Well, from my experience with honey locusts, I've had to cut many honey locusts that, are the result of land use history going back, many, many years, no doubt, and remnant prairies that are have a problem of these trees. And you just, you cut them. You have to be real careful about the thorns, and making sure that sometimes they will end up, on branches that end up laying on the ground, and then sometimes the person can step on them. But cut them and treat the stumps, and that is usually pretty effective. That'll kill the plants. They won't come back. And we treat the stumps with, I always treat the stumps with triclopyr, which is a product found in Garlon. Garlon's the trademark name, Garlon 3 or Garlon 4. It's a commonly used stump treatment herbicide. Some people, I think, use glyphosate or Roundup to treat stumps, but I don't think that works nearly as good as triclopyr.
Okay.
I've treated lots of stumps.
Okay. Anyone have any questions at all or comments? Oh, here we go. We are currently having a problem with black locusts. Are there any management similarities between them and honey locust?
Black locust seems to be much worse, much worse. So I'll have to do, maybe you can send me your email with that question. I'll have to do a little bit of research, so to speak, and review. I'm on a committee that manages an area called Big Sand Mound. Big Sand Mound is a natural area in Muscatine and Louisa counties in southeast Iowa. It's a huge, big mound of sand deposited both by alluvial processes and aeolian wind-blown processes. But the point being, Big Sand Mound is this very, very cool, important natural area. It's one of the most important sand prairies in the state. And it has, for many, many years, had a very, very bad black locust problem. I've seen black locusts on many other sites too, mainly in the southern part of the state. Eddyville Sand Dunes is another place where it's been really bad. At Big Sand Mound, we have had success with black locust, but it's taken a while to get to a point to find something that's working. And it was a combination of cutting and treating and chemical. So it's, again, pretty vigorous and time consuming, but I don't see that there's any other choice really if you've got it, because it's just going to get worse if you let those trees persist and seed out. So I can't tell you exactly the strategy because it was kind of a complicated approach that we used there, but I can go back and dig that up.
And I did add Tom's email address to the chat area. So Dinah, you could follow up with Tom that route. So
I think part of it will depend on what size you have. I've dealt with them at a small size, probably a meter at the most tall. That hasn't been so difficult. Again, treating those little stems when you cut them. What we had at Big Sand Mound were large trees, and so that was a more difficult task there. But
okay, and I don't see any other questions,
okay.
But I do have a question for you. So I was in a different state recently and doing a little bit of hiking in one of the parks. And they were doing some woodland management restoration, and it was buckthorn management. And they had little bags around the stumps of the removed buckthorn, and they were labeled buckthorn management. Do you know anything about that?
I don't know anything about that. Little cloth bags?
No, little plastic bags.
Oh, plastic bags?
Yes.
But they were attached to the stump of a buckthorn?
They were covering the buckthorn stump, and they were
covering the stump. Oh,
yes.
I don't know for sure what they're trying to. Sounds like they're trying to keep something away from those stumps or something. But I don't know for sure.
I should have taken a picture of it, but I've never seen that. So I thought, oh, I'll ask Tom. So okay.
Well, I've done a lot of buckthorn work at Chautauqua in Polk County, and again, that's the same kind of thing as any other woody thing like honeysuckle. Basically cut and treat is what I would use normally for that. Cut it and treat it with triclopyr. It's just it just involves a lot of work, but
okay. All right. Well, let's see. So I don't see any more questions here. Okay. So want to thank you, Tom, for presenting today and joining us. And thank you, Tiffany, for running things behind the scenes.
Sorry for the disruption, by the way. I told Pat, electrical people that service us here came out and changed the meter out. So the electricity got turned off briefly. That's why I lost you there.
Okay. Yes. And what timing?
What timing? Yeah. I went down. I kind of complained to the guy. I said, "Hey, I wish I would have known about this. I'm in a webinar right now, and I lost my connection." He was very sorry, of course, but I said, this happens like over a 2-hour period once a month, and you just happen to pick the worst time.
Yeah. Yeah. Well, it
anyway,
happened.
It happened.
We're glad that you were able to rejoin
Yeah,
us.
get back on. So one more, I guess, in September.
Let me see.
Is that still
Yes.
the plan?
Well, we have one in August, and
We
we do.
didn't do the one in July, so we've only had
Right.
3 so
Yeah,
far.
yeah. So we have one in August, and then we bumped out one to replace the July. We have one in September.
Right.
So, yeah, yeah. So it's August. Oh wait, no. What am I saying? Today's the August. We have one more September. I had to flip my calendar. So the last one I have on September 28th. So.
Yep, that's what I have.
Okay.
Yep.
Alrighty, sounds
Good.
great. Well, thank you all for joining us. Glad that you're here with us today. So we have one more in September. Looking forward to seeing you then. Well, I'm sure we'll have a seasonal change occurring, and we'll see different stages of plant growth at that stage as well. So have a nice afternoon, everyone. Take care, and we'll see you in September.